Well, greetings. We're going to learn how to combine some vectors. We're using algebra to add two vectors together. And in my example today, I'm going to be adding vector A, which is a 20 Newton force applied 20 degrees north of the horizontal. And I'm going to add to that vector B, which is a 25 Newton force applied at 45 degrees north of the horizontal. In the picture that's shown here, I'm going to follow the rules from our text, which say the first thing we should do is define our coordinate system. So as is common, we're going to say that up is positive, down is negative. And we'll also use the idea that to the right is positive, to the left is negative. All right, let's focus on vector A first of all. The next thing that we do when we're trying to combine vectors algebraically is we take our vectors, if they're at an angle like this one, and we resolve them into their components. In other words, I'm going to break this vector into an x component and a y component. And I'm going to use some trigonometry to do that. So the x component of this vector, the x component and the y component, I've labeled here as purple arrows. And you'll notice if we kind of rearrange those components, we end up with a right triangle with theta being defined as 20 degrees and our hypotenuse is 20 newtons. So to find the y component of vector A, I'm going to use the sine function. Recall that sine is equal to opposite over hypotenuse. In other words, the sine of 20 degrees should equal the y component of vector A divided by the hypotenuse, which is 20 newtons. And so rearranging that equation and solving for the y component of vector A, I end up with 6.8 newtons. I'm going to do a similar thing to figure out the x component. Again, this is one side of a right triangle. This time, the function that I need to use is cosine. Cosine theta equals adjacent over hypotenuse. So that should give me the value for the x component of vector A. And there's the solution. Cosine 20 degrees equals a sub x divided by the hypotenuse, 20 newtons. Rearranging that equation, I calculate that the x component of vector A is 18.8 newtons. Always a good idea to look at your final values, make sure they make sense. Of course, we know that the two legs of the triangle must both be smaller than the hypotenuse, which they are. So these seem like reasonable results for our x and y component of vector A. I'm going to do the same for all the vectors I'm combining. So I'm going to do the same thing here for vector B. I'm going to resolve it into its two components, which I've done already. I did this using the sine and cosine function again. And since this angle is 45 degrees, we end up with an x component and a y component. They're both equal, and those are 17.7 newtons. Now, this would be a good time to go back and look at my last x component vector that I found for vector A. It is written on my page as 18.8 newtons, but recall that we've defined that direction as the negative direction. So later on when I put these together, you'll notice that we're going to use that value as a negative 18.8. All right, so the next step of this process, once you've resolved your vectors into their x and y components, is to add or subtract the component vectors. We're going to do this in each direction. So let's look at the two x components from these two vectors. I've got one that is negative 18.8 newtons. That's the one that's pointing to the left. One that is positive 17.7 newtons. And so the x component, the combination of those two values, I get minus 18.8 plus 17.7, or negative 1.1. That is the sum of those two vectors, my x component vectors. I'm going to do the same for the y component. In this case, they're both pointing up. So I will use positive values for both of these. And so my y components give me the sum of 6.8 and 17.7, which is 24.5. That is my y component. And so We've now taken these two vectors, vector A and B, and combined them. So mathematically, we know that the sum of the two vectors is going to have a y component up 24.5 and an x component over to the left 1.1 newtons. All right. So this is where I end up then. I'm going to go ahead and draw what we'll call the resultant vector in blue here. And the resultant vector, we need to know the amount, the size of the magnitude of that vector. So we still have a little bit more math to do. You'll notice that in drawing this resultant vector, I went up and then over to the left and again created a right triangle. So to find the value of r, I'm going to use a familiar theorem, one that you know is Pythagorean's theorem. And that's because this right triangle allows me to do that. So in my case, I'm going to say r squared equals rx squared plus ry squared, where rx and ry are defined as the result, the x component, and the y component. So this gives me, I got to take the square root of negative 1.1 squared plus 24.5 squared, and that gives me a value of 24.5 newtons. That is the magnitude of the resultant vector. And again, I find that using Pythagorean's theorem. All right, and then finally on to the last step. If we want to know, and we will, we want to know the angle that this vector is acting. In other words, we want to know this new theta here that I've labeled. In this case, I'm going to use the function tangent. Tangent is equal to opposite over adjacent. So the tangent of that angle should equal 1.1 divided by 24.5. And so solving this equation gives me a theta equal to 2.6 degrees. That's the technique that we're going to use for combining vectors that are not easily combined, that are not horizontal or vertical vectors. We're going to break them into their components. We're going to add up their components, and then we'll use some trig functions along the way. I hope this makes sense to you. If not, contact me and I'll give you some more help with these problems. Otherwise, good luck.